Okay, so next we continue with Newton's law of cooling or warming. Newton's law of cooling or warming states that the rate of change of the temperature of a body is proportional to the difference between the body temperature and the temperature of the surrounding medium. The model is expressed as dt dt equals to kt minus tm subject to T0 equals to T0 and T1 equals to T1, where T is the temperature of the object at time T, Tm temperature of the surrounding medium, dt the rate of change of the temperature, and T minus Tm the difference between the object's temperature and its surrounding temperature, and K is a constant of proportionality. Okay, so untuk Newton's law of cooling or warming, okay, so kat sini kita ada third problem, which is Newton's law of cooling or warming. Maknanya kita akan apply Newton's law ni dalam penyejukan dan pemanasan sesuatu objek. Okay, Newton's law of cooling or warming. Okay, the model is expressed as dt equals to kt minus tm. Okay, so kat sini dia still sama macam population and radioactive, population growth and radioactive decay. Okay, cuma kat sini dia ada tambahan tm. So kalau kita compare balik, kalau population growth, we use dp dt equals to kp, and then radioactive decay dm dt equals to negative km. Okay, then last one, temperature dt equals to k. Okay, but here temperature we use two temperature which are T and Tm. So kat sini je beza, dia ada dua temperature. Okay, and then all these three problems use separable. Sebab tu tajuk dia yang tiga problem ni dia adalah bawah separable differential equation. Okay, population growth, radioactive decay, and then another one is temperature or Newton's law of cooling and warming. Okay, so T, yang capital T, this one is for temperature of the object. So kat sini, temperature of object. Kita ada dua kat sini, suhu, okay, which are temperature of object, and then another one kita letak Tm, temperature of surrounding medium. Maknanya yang ni ada satu lagi temperature of surrounding. Surrounding ni maknanya persekitaran. And then yang ni tetap sama, kadar perubahan temperature, which is dt. Okay. And then next, T minus Tm is the difference between the object's temperature and its surrounding temperature. Maksudnya nanti untuk temperature kita ambil nilai temperature object tolak dengan surrounding temperature, and then K is a constant proportionality. Okay, so yang itulah formula untuk Newton's law of cooling or warming. Okay, the equation 3.5 is solved by separating the variables and integrating both sides of the equation. Okay, yang ni pun step dia sama dengan population growth and radioactive decay. Okay, so if you can see here, okay, I rewrite the equation dt equals to k t minus tm. Okay, so this is the first step, first mathematical expression, and then in the second step kita guna separable. Since kita ada function t kat sini, so kita pindah sebelah kiri, dia akan jadi 1 minus 1 over t minus tm. Okay, so this one k kita kekalkan, and then dt bawa ke sebelah kanan. Okay, that's we can integrate both sides sebab dia dah jadi separable differential equation. Okay, integrate yang ni dia akan dapat ln t minus tm, and then this one dia akan dapat kt plus c. Okay, sebab dia yang ni cuma constant, so you just put t lah kat sini bila kita integrate. Okay, kita nak hilangkan ln, kita akan letak eksponen kiri dengan kanan. Okay, so dia akan jadi eksponen ln t minus tm equals to eksponen kt plus c. Okay, and then step number 5, bila dah jadi exponent ln, dia akan dapat kat sini terus T minus Tm. Kat sini, kita pecahkan EKT dot EC. Okay, T number 6, T minus Tm equals to this one. Yang ni function. Sebab function, sebab dia ada T kan. Dia ada variable T. So, this one is a function. So, kita tak boleh nak simplify. But this one exponent C. C constant. Kalau awak ada nilai exponent, awak letak je apa-apa nilai constant, dia still akan jadi satu nilai constant. Okay, for example, E8. Contohnya C8. So, awak akan dapat nilai constant. Apa-apa nilai kan, bila awak tekan calculator. Okay, tapi kalau awak ada E8X, dia tetap E8X. Tak boleh nak simplify sebab dia adalah function. Sebab dia ada X. Okay. So, since constant, dia boleh tukar kepada dekat sini. Kita gunakan A. Okay. So, this one A. A-E-K-T. So, kita cuma nak T. Okay. Tm awak pindah ke sebelah kanan. A-E-K-T plus Tm. Okay, so, sorry, Tm. So, this is your general equation of temperature of the body at any time T. Okay, then find the specific solution with the exact value of A and K by applying the conditions given. T0 equals to T0 and T1 equals to T1. So, aim kita sama dekat sini. Kita nak cari nilai A and K. Kita nak cari nilai kat sini. A dengan K, and then kita akan gunakan, biasanya dia akan bagi dua information dalam soalan, and then you can solve it. Okay. Okay, so let we discuss example 3.5. Okay, so in example 3.5 here, a steel bar heated to 1380 degree of Celsius is put in a room with constant temperature of 80 degree Celsius. After half an hour, the bar cools to 1000 degree Celsius. Okay, what is the temperature of the bar after 1 hour? And then another question is, how long will it take in minutes for the steel to cool to 300 degree Celsius? Okay, so first of all, we need to write the information that given. Okay, so first, a steel bar heated to 1380 degree Celsius. Okay, so it means that for the first information, when T equals to 0, the temperature is 1380. Okay, so this one is first information, and then is put in a room with constant temperature. Okay, so ada satu lagi temperature which is room temperature. Okay, that is 80 degree of Celsius. After half an hour, okay, so it means that half an hour means T equals to half an hour, or you can write in minutes. So, T equals to 30. So, kat sini kita tukar, kita boleh guna minutes. So, T equals to 30. And then, the temperature is equals to 1000. Okay. So, you have this three information here. Okay. So, now, how to solve this one? Okay. Since you have this all the information, okay, so solving the differential equation as the following. Okay, so now we write as the equation start with dt equals to kt minus tm, and then we still do this step. Okay, so kat sini tm we can substitute with 80 from the information given, which is room temperature is 80 degree. Okay, so apa ni, step dia sama, maknanya kita bawa yang ni ke sini, dia akan jadi 1 minus T minus 80 dt equals to K dt. And then we can integrate both side. Okay, this one ln T minus 80 equals to KT plus C. Okay, nak hilangkan ln, letak eksponen kiri dengan kanan. So, dia akan jadi T minus 80. Okay, this one KT plus C. Okay, yang ni dia akan jadi T minus 80 equals to yang ni dia akan jadi EKT.EC or equals to AEKT, because this one you can write as A. Okay, any constant. So now T equals to AEKT plus 8T. Okay, so kita akan dapat this general solution of temperature. Okay, the next step is to apply the conditions given to find the values of A and K. So sama aim kita nak dapatkan nilai A dengan K. So from these two information here. Okay. So kat sini tadi yang saya kata bila T sama dengan 0, temperature 1380. And then this one when T equals to 30, the temperature is 1000. So from these two information, you can find the value of A. Okay, so step dia sama juga. So awak akan dapat nilai A. And then, okay, you can also get the value of K, which is 46/65. Okay, so step dekat sini. Okay, step dekat sini pun sama macam yang sebelum ni. Okay, letak lon kiri dengan kanan. And then kat sini sebab kita nak turunkan, kita nak cari K. So kita nak turunkan 30K ni ke bawah. Dia tak boleh turun macam tu. So kena letak lon. Sebab apa kat sini bila ln eksponen X dia akan sama dengan X. So kalau ln eksponen 30K dia equals to 30K. So kat sini kekal ln 46/65. Okay, so you can calculate the value of K which is 1/30 ln 46/65 or negative 0.01152. So you substitute into the general equation yang tadi tu kan, T equals to AE negative KT plus 8T. Okay, so ganti tempat A which is 1300 and then tempat K. Kat sini tertinggal T so negative 0.01152T. Okay, so first question dia kata nak cari temperature bila after 1 hour. So 1 hour since kita guna tadi minutes which is 30 minutes kan. Okay, so kalau 1 hour means 60 minutes. Okay, so 60 minutes into equation 3.6 give, you just substitute dekat T ni. So you get the temperature which is 731.27. The temperature of steel bar after 1 hour is 731.27 degree of Celsius. Okay, so kalau ada yang guna macam tadi kan, saya guna T equals to 0 and then after 30 half hour kan, 30 minutes and then you can find kat sini adalah nilai temperature dia berapa kan. Kat sini temperature dia, so kat sini 60 minutes, so the temperature is kalau yang ni kalau awak guna dalam minutes sebab dia nak dalam minutes kan. Okay, dia nak after 1 hour, so kita boleh guna jugalah, ataupun ada yang nak guna hour. So you can write as T0 temperature berapa, and then this one you can use half sebab yang ni dalam unit hour, and then barulah T equals to 1 temperature berapa. So this one you still get the same answer sebab kat sini kita guna 30 dengan 60, kat sini kita guna half and 1 sebab dalam case 1 tu dia cuma nak nilai temperature. Okay, next. Okay, next question. Okay, question B. Okay, in this part, we will determine the time needed for the steel bar to cool to 300 degree of Celsius. Okay, yang ni pun sama. Okay, we still use this equation. Dan equation asal ni, kita guna yang T equals to 1300 E negative 0.01152T plus 8T. Okay, so yang first tadi bila T equals to 60, what is your temperature? Okay, so question 2, what is your time when temperature equals to 300 degree? So dia sebenarnya macam ni, bila kita once kita dah ada equation ni, yang mana equation ni kita kena cari nilai A dengan K, find A and K. Okey, bila awak dah dapat nilai A dengan K, so dia tak ada problem. Maknanya yang ni, contohnya soalan A tadi, bila diberi time, awak boleh cari temperature. And then soalan B, bila diberi temperature, awak boleh cari time. So, kalau time tadi awak ganti tempat T. Okay, now kalau temperature awak ganti tempat T kat sini, temperature. Okay, so it means that this one, you substitute the value of A, K and temperature to find the value of T. Okay, so samalah, maknanya solution dia awak akan solvekan using this step. Okay, masukkan nilai semua. Then letak lon kiri dengan kanan. So you can find the value of T. So it will take approximately 154.21 minutes for the steel bar to cool to 300 degree of Celsius. Sebab tadi dia nak dalam minutes kan. So solution kita ni memang dalam minutes lah. Sebab tu yang first tadi pun memang kita cari dalam minutes. So sebab tu tadi kita buat 60 kan. So this is your answer, 154.21 minutes. So yang ni awak boleh try buat step ni supaya kita mahirkan solution dia kan, how to solve this one. Okay, so we continue with example 3.6. Okay, a can of orange juice is taken from a freezer and placed in a room with constant temperature of 20 degrees Celsius. After 10 minutes, its temperature increased from 5 degrees Celsius to 9 degrees Celsius. Determine A, the time needed for the temperature of the orange juice to be 18 degrees Celsius. And then another one, the temperature of the drink after 30 minutes. Okay, so sama juga macam example sebelum ni. Okay, first we take the information given. Okay, so this one, okay, 20 degree Celsius is a room temperature. Okay, so this one is a room temperature. So you can write this one, Tm equals to 20 degree of Celsius. Okay, then after 10 minutes, its temperature increases from 5 to 9 degrees Celsius. Okay, dekat sini dia tak inform, dia tak sebut pun initial ataupun apa kan. Cuma dia kata after 10 minutes. Okay, after 10 minutes, so it means that kalau initial, so T equals to 0, so temperature is 5. And then after 10 minutes, T10, so your temperature is 9 degree of Celsius. Okay, so from here, kat sini awak kena pandai trick question. So kadang-kadang information tu dia tak bagi direct. So dalam kes ni dia kata after 10 minutes, its temperature increases from 5 to 9. So it means that we need to know that after 10 minutes, the temperature is 9. And then for the initial, which is T equals to 0, so your temperature is 5. Okay, so first, the time needed for the temperature of the orange juice to be 18 degree, and then the temperature of the drink after 30 minutes. Okay, so we have the same step. Okay, A, dia nak time. Okay, what is your time when temperature is 18 degrees Celsius? Kan, dia nak ni time needed. Okay, when temperature 18. And then for B, the temperature of the drink after 30 minutes. Okay, so it means that T equals to 30. And then temperature equals to what? Okay, so this one, dia nak kita cari semua value ni kan. Okay, so first step, kita dah ada equation which is T equals to AEKT plus Tm. Okay, so kat sini awak dah boleh substitute dah. Tm equals to 20 degree of Celsius. Okay, so boleh substitute kat sini. So aim kita untuk step seterusnya, kita nak cari find A and K. Okay, so step dia sama macam yang sebelum ni. Okay, so dekat sini we start from this equation. So awak buatlah macam yang kita buat selalu tu sampai kita dapat yang ni. So kalau boleh dalam exam kita boleh show kan. Awak show daripada step ni Step 1 sampai step yang last ni sampai dapat yang ni. Okay, macam mana kita separate and then kita integrating until you get this mathematical equation. Okay, then after you get this mathematical equation, barulah kita masukkan information yang diberi to find the value of A and K. Okay, so next step. Okay, so apply. Okay, this one Okay, apply the conditions given in equation 3.7. Yang ni lah masukkan dalam equation ni. Okay, to find the values of A and K. So step ni sama juga, awak boleh tengok balik step sebelum ni. So this one for the first information, when time equals to 0, your temperature is equals to 5. So you substitute into this equation. So tempat T ni kita ganti dengan 0 and then tempat temperature kita ganti dengan 5. So awak akan dapat nilai A which is negative 15. Okay, next you can use second information here. Okay, for second information, okay, when time equals to 10, sebab dia kata after 10 minutes and then your temperature is equals to 9. Okay, temperature equals to 9. So substitute into equation. Okay, equation ni kita dah boleh ganti dah. Nilai A equals to 15. Kat sini kita dah boleh ganti A equals to 15. So, then T equals to 10 and then temperature equals to 9 to find the value of K. Okay, step dia sama lah. Macam ni, bila awak solve, awak akan dapat E10K equals to 11/15. Okay, and then taking the natural log on both sides yields. Okay, so kita nak turunkan K ke bawah, kita kena letak ln kiri dengan kanan. Okay, so bila kita dah letak ln kiri dengan kanan, so kat sini automatic dia akan jadi 10K equals to ln 11/15 and then solve for K equals to negative 0.03102. Correct to 4 significant digits. The equation describing the temperature of the orange juice at time T is, so awak akan dapat this equation. Equation ni yang dah ada nilai A and K. Okay, this one A, this one K. Okay, we need to find the time when the temperature of the juice is 18 degrees Celsius. Okay, kita kena cari masa bila temperature tu adalah 18. Okay, so nak cari masa, yang ni tak ada problem. Maksudnya untuk question A, what is your time when temperature is equals to 18? Okay, so masukkan dalam equation yang ni. Okay, negative 15E negative 0.03102T plus 20 equals to 18. So kita ganti nilai tempat temperature. Okay, so after you solve this one, ni sama juga nak turunkan T, kena letak ln kiri dengan kanan. Okay, and then okay, so this one, okay, awak solvekan ln E semua tu, so you get the value of T which is 64.95. So it takes about 65 minutes for the orange juice to have a temperature of 18 degree of Celsius. Okay, so this one for question A, and then for question B, to estimate the temperature of the orange juice after 30 minutes, just substitute T equals to 30 into the equation 3.8. Okay, yang B ni pun sama, means that bila awak dah ada nilai, okay, so bila awak dah ada equation tadi kan, equation yang ni, okay, equation yang asal ni kita dah ada nilai K dengan A. Okay, and then you just substitute the value of T sebab dia nak the temperature of the orange juice after 30 minutes. So what T equals to 30 and then what is your temperature? So after you substitute the value of time which is 30, so you calculate here, you get 14.09. So after 30 minutes, the temperature of the juice is estimated to be 18 degree of Celsius. Yang ni sebenarnya kalau awak tak nak bunda pun nak gunakan solution yang ni pun boleh juga, maknanya 14.09 degree of Celsius ataupun boleh bunda 14 degree of Celsius. Okay, so this one for example 3.6. Okay, next for example 3.7. The normal body temperature of a hen is 40 degrees Celsius. At 5 p.m., a farmer found that the temperature of a dead hen is 38 degrees Celsius. At 7 p.m., the temperature of the hen drops to 34 degrees Celsius. Assuming that the surrounding temperature is 30 degrees Celsius, determine the time of death. Okay, so kat sini dia berkenaan dengan suhu selepas dan sebelum ayam tu mati. Okay, so kita still lagi guna cara yang sama. Okay, so first of all, okay, kita ambil dulu maklumat kat sini. Okay, maklumat kat sini, dia kata apa? The normal, assuming that the surrounding temperature. Biasa kita cari surrounding temperature which is 30 degree. Okay, so this one is your Tm. Okay, Tm equals to 30 degree of Celsius. So, boleh masukkan dalam ni lah. Masukkan dalam equation kat sini T minus Tm, and then you will get this mathematical equation. Macam saya cerita tadi, biasanya awak tulis je step dari sini ke sini. Always write the step how to get this mathematical equation. Okay, so dekat sini, kat mana kita nak cari initial time, initial temperature. Okay, when T equals to 0, dalam case ni, at 5 p.m., a farmer found that the temperature of a dead hen is 38. Maksudnya kat sini pukul 5. Okay, pukul 5 dia dah jumpa temperature masa dia mula-mula mati tu, ayam tu. So, temperature dia adalah 38. Okay, so kat sini we set that T equals to 0. So, the temperature is 38. And then at 7 p.m., the temperature of the hen drops to 34 degrees Celsius. Okay, so kat sini T equals to 2. So the temperature is equals to 34 degree. Okay, 34 degree. Okay, then dekat sini, okay, 5 and then 7. Maknanya kat sini T2 kan. Okay, T2. Okay, the temperature of the hen drops to 34, assuming that the surrounding temperature is 30 degrees Celsius. Determine the time of death. Okay, so kalau tengok kat sini, yang ni kadang ada student confused. Dia tak letak T0, dia letak T equals to 5. So kita tak boleh, kita bukan ambil masa kat sini. 5 and 7, kita ambil initial. So, yang mana kita anggap initial, kita akan assume kat sini T equals to 0. And then, kalau dikata 7 PM, kita akan ambil T equals to 2. Sebab 2 jam selepas tu kan. Okay. So, okay, lepas awak dah dapat yang ni. Okay, so... Okay, so kita akan masukkan information kat sini. Apply the conditions given to find the values of A and K. Okay, macam biasa kita cari nilai A and K. Kat sini first kita masukkan when T equals to 0, temperature equals to 38. And then after you solve, substitute into this equation. Okay, so you will get the value of A, which is 8. Okay, so next information, when time equals to 2, your temperature is 34. So substitute into temperature here, which is, substitute time 2 and then your temperature is 34. So you will get the value of K. So samalah yang ni, bila kita ada exponential function and then take natural log both side to get the value of K. So your K is 0.3466. The equation describing the temperature of the dead hen at time T is, so awak dah gantikan kat sini, dah ada nilai A which is 8 and then dah ada nilai K which is negative 0.3466 T. So you get this equation. Okay, so next question ditanya at the time of death the temperature of the hen is 48 degree Celsius. So ditanya bila masa ayam tu mati, bila temperature dia adalah 42. Okay, so kat sini maknanya kita nak cari what is the time when temperature equals to 42 degree of Celsius. So just use the same formula. Okay, use the same formula. Okay, kat sini kita dah ada A, kita dah ada K. So you substitute temperature, then you can find T. Okay, so solution dia sama juga step dia. Okay, solve. Dia akan jadi exponent negative 0.34660 equals to 3/2, and then letak ln kiri kanan, then solve for T. So you get T is negative 1.1698. Okay, the negative sign indicates that the hen died 1.1698 hours or 1 hour 10 minutes before 5 PM on the same day. Nilai negatif ni maksudnya dia melambangkan, okay, yang dia mati pukul 5, then pukul 7 maknanya dia mati sebelum ni. So therefore the hen died at about 3:50. Sebab kat sini suhu dia this one 40 degree of Celsius. So sebab yang ni pukul 5 tu yang dia mula-mula jumpa kan, and then pukul 7 tu dia check suhu. Then bila awak dapat nilai jam yang negatif, maksudnya dia mati sebelum pukul 5. So you minus 5 minus negative 1.1698. So the hen died at about 3:50 PM. Okay, so this is 3 subtopic. So kita ada 2 lagi subtopik. So untuk 3 subtopik ni dia menggunakan separable equation. So saya buat kesimpulan sikit dekat sini. So you have first population growth dP dt is equals to Kp, and then you have radioactive decay dm dt equals to negative Km, and then Newton's law. Number 3, dt dt equals to k t minus tm. Okay, yang ni awak akan buat sampai dapat equation P equals to AEKT. This one pun dia akan dapat M equals to AE negative KT. And then yang ni awak akan dapat temperature equals to AEKT plus TM. Okay, so daripada step ni sampai dapat yang ni awak boleh show lah, dan dia sentiasa sama. Step daripada first step ni ke untuk dapatkan mathematical equation, step dia sentiasa sama. So awak just follow je, maknanya setiap kali soalan tu boleh buat ya semua, and then boleh guna step yang sama. Then bila dah dapat equation ni, baru kita masukkan nilai untuk kita cari A dengan K. Okay, so bila dah dapat A dengan K, baru boleh jawab soalan sama ada nak cari M ataupun T. Yang ni nak cari P ataupun T. Kat sini nak cari temperature ataupun time. Okay, so 3 ni dia menggunakan konsep separable. Okay, separable differential equation. Okay, so now you can do exercise 3.1. Okay, exercise 3.1 ni kalau tengok kat sini, yang ni dia lebih kepada have growth rate kan. Okay, so soalan 1 lebih pada population growth, soalan 2 radioactive decay, and then soalan 3 yang ni untuk temperature. So this is the answer. You can check the answer here. Okay, so that's all for chapter 3 for first 3 parts.